Alright guys, welcome back to 12.8 Mixed Expressions and Complex Fractions. Simplified mixed expressions. Recall that the number, like 2.5, is a mixed number because it contains the sum of the integer 2 and the fraction 1/2. The expression, like 3 plus the quantity x plus 2 over the quantity x minus 3, is called a mixed expression because it contains the sum of a monomial, 3, and a rational expression, x plus 2 over x minus 3. Changing mixed expressions to a rational expression is similar to changing mixed numbers to improper fractions. Example 1. Mixed expressions to rational expressions. Simplify the following. 3 plus the quantity of 6 over x plus 3. So, example number 1. We have the quantity 3 plus 6 over x plus 3. Well, as you recall, we cannot add it as is because we have unlike denominators. We have a denominator of 1 and a denominator of x plus 3. Well, we know in order to add them, we need to get our first fraction to have the same denominator as our second, which is x plus 3. So we have to multiply our first expression by this denominator of x plus 3. So x plus 3 over x plus 3. 3 times x is 3x, plus 3 times 3 is 9. Now we can add it to that 6 all over our denominator of x plus 3. Bring your like terms together, and we get 3x plus 15 over x plus 3. And that's our final answer. But that's a simple addition problem. Now we're going to get into complex fractions and what we do in order to solve those problems. Simplifying complex fractions. If a fraction has one or more fractions in the numerator or the denominator, it is called a complex fraction. You simplify an algebraic complex fraction in the same way that you would simplify a numerical complex fraction. So numerically, they're just saying what happens if you have the fraction 8 over 3 divided by the fraction 7 over 5. Putting it over a division bar just makes it look more complicated, but it's the exact same thing as 8 over 3 divided by 7/5. So 8 over 3 divided by 7/5. Well, we know to be able to solve this problem, we multiply by the reciprocal. 8 over 3 times 5/7. 8 times 5 is 40. 3 times 7 is 21. And so while it's a complex fraction, it's still simple to solve once you go back to your basic rules. So this is the numeric version of it. And then if we look at the algebraic way as they break it down in your book, they give you the fraction a over b divided by the fraction c over d. And they go through the same process. That this is really just a division problem, even though we have the division bar instead of the normal division sign. So a over b divided by c over d, multiply by the reciprocal, a over b times d over c. And then you get this algebraic proof that anytime something is in this form of a fraction divided by another fraction, you can simplify it or use the rule to speed up your process of it's always just a times d over b times c. A times d over b times c is always the way this kind of fraction is going to multiply out. So you can save yourself the time of writing out these steps once you get into the habit of it. I always remember the top and bottom, inside top and bottom. So external top and bottom, internal top and bottom. And then they give you the key concepts on the top of the next page, which is just this. Anytime you have, again, a over b divided by a over c, it multiplies out as a times d over b times c. We're going to skip example 2 and go straight to example 3, which talks about how to do this. So example 3, complex fractions involving monomials. Example number 3. And we're given the fraction, I'm going to do it all the way over here because it takes some steps. X squared times y squared. So x squared times y squared being over a is being divided by x squared y over a cubed. So again, fraction 1 is being divided by fraction 2. And so what we're going to do is we're going to rewrite it the way we would normally approach this kind of problem if it were written with the normal division sign. So I'm not solving anything, I'm just changing this to a division sign so it gets a little bit easier to see. So x squared y squared over a is being divided by x cubed y over 3. And now this looks way friendlier. So now multiply by your reciprocal. So x squared y squared over a times 3 over x squared y. Again, much friendlier looking. I'm going to erase this just so that our eyes follow where we are more clearly. And now you can just start cross-canceling. I can cancel out my x squareds. I have a y squared and a y, so this y is going to cancel out, and this is going to become y to the first. And I don't have anything to cancel out with my, this is a to the third. Whoopsie, not a 3. There we go. And now I have more to cancel out. This a is going to get canceled out, and this 3 is going to become a 2 because I pulled out an a. And now I don't have anything left to cancel. So I'm left with y times a squared. We always write it in alphabetical order, so it's going to end up being a squared y. And that's it. So again, take the complex problem and write it in a way that you're used to with a normal division sentence. Then rewrite your division sentence with multiplication by the reciprocal, and you're good. All right, example 4. And I'm going to have to turn my little thing because this is a much longer problem to solve. That way we have more room. Whoop. All right. Making sure you can see the tip of the board right there. All right. We have the expression for example 4. Still can't quite see it. Ah! Y'all are going on a journey right now with my tripod. There we go. All right, we have the problem for example 4. A minus the second expression of 15 over a minus 2. Then this entire expression is being divided by a plus 3. So it's a little bit longer because we're going to have a few steps. The numerator contains a mixed expression. Step 1 is rewrite it as a rational expression. What that means is we have the quantity a minus 15 over a minus 2. Well, we can't do that subtraction until we have a like denominator. So just to get a little more room here, we need to get a common denominator of a minus 2 so that we can pull together our numerator before we go any further. That means I need to multiply my first term by my common denominator of a minus 2. So a minus 2 over a minus 2. True. And now I'm going to get a times a is a squared. A minus 2, or a times negative 2, is going to be negative 2a, and then it's going to all be over the common denominator. So I'm going to go ahead and write that out. just writing out what I just said of a squared minus 2a, still minusing that 15, all over a minus 2. There we go. And now we have our common denominators and we're good to go. But we still have this division, as well as a polynomial up here that is best to factor right away. That way we don't get lost or forget about it later. So it's really your choice. You can either factor it right away or do your division bar. And honestly, because I don't have room up here, we're going to do the division bar first. So we're just going to rewrite our expression now as division with the division bar. So I have a squared minus 2a minus 15 over my denominator of a minus 2 is being divided by 1 over, hold on one second. Oh, yes. Is being divided, sorry, I was checking my book really quickly. Is being divided by a plus 3 over 1. The reason I got stumped right there is because I wanted to write it as 1 over a plus 3 from the beginning, because I got stuck in thinking that this a minus 3 was a denominator. It's not a denominator, it's the entire expression, and it's really a plus 3 as a whole number. Well, any whole number by itself is division by 1. So it's actually a plus 3 divided by 1. Because even though it's in the denominator position in our original expression, it's still an entire quantity. And that quantity is really over 1. I hope that makes sense. And so now when I go to multiply it, I have to multiply by the reciprocal of 1 over a plus 3. So again, I need to factor this, and then I'll write my whole new expression. So what are my factors of negative 15 that sum to negative 2? Well, that's going to be negative 5 and a positive 3. So factoring my original numerator, I have a minus 5 times a plus 3 all over a minus 2. Now rewriting my division as a multiplication of the reciprocal times 1 over a plus 3. And now my job is to start canceling. I have a plus 3 and a plus 3, so that can cancel out. And I don't have anything else to cancel out, so I just have a minus 5 times 1, which is just a minus 5, over, this becomes a 1, 2 minus a times 1, or a minus 2 times 1. So then my final answer is a minus 2, and that's my final answer. All right, guys, you are free to start your homework now.